Now let's focus on finding the area between two curves. Now recall the area under a curve is represented by an integral. Let's consider the graphs to the left where we have the f of x function in blue above the g of x function in green. In order to find the total accumulated area between these graphs and the boundaries where x equals a and x equals b, we would write the integral from a to b of the function f of x, the function on top, minus g of x with respect to x. It's important to note that we need to know which function is higher on the interval. We can tell here in a graph, but when just given equations, we may not know. And we always want to subtract away the area that's underneath the lowest function in order to only have the area between the functions left. So in example A, we want to find the bounded area between the functions h of x equals the square root of x plus 2 and p of x, which equals a negative 1/2 x squared plus x plus 4. And it's going to be on the interval between -1 and 3. So x equals -1, x equals 3. Before we determine how to set up our integral, we need to know which function is on top. Let's go to Desmos so we can put in both of those functions. I'm going to just use, well, we can use h and p. H of x that equals, and if we come down here to our keyboard, we can find the square root button and then put in x plus 2. So there's our first graph. There is h. Click on number 2 down here. We can put in p of x, which equals a negative 1/2 x squared plus x plus 4. And then there's our second graph. And if we recall, here between -1 right here and 3 right here, our p, in other words, the quadratic, is above our square root. So now we can find the area of that shaded region there between p of x and h of x by taking the integral from -1 to 3 of the quadratic function, negative 1/2 x squared plus x plus 4, minus the lower function, which was the square root of x plus 2 dx. And we can take that integral by hand, but knowing that we're going to be working with a lot more complicated integrals, I'm going to let you use your calculator on some of these. To find that integral in Desmos, we can use the keyboard again if we want to. We can go to Functions, down to the Calculus functions, and we can put in our integral symbol. We can also just type in int, stop there, and then it will show up. We're going from -1 to 3. Now here's the cool thing about Desmos. We can retype the entire functions, or since they're already labeled in previous graphs, we can just tell it to take the function g of x minus the function f of x. And don't forget to do it with reference to x. And we will get our integral, our area between those two curves, as approximately 8.55. But just for kicks, let's go ahead and do it by hand and see if we're correct. So on the first one, when we take the integral, it's going to be an x cubed. Divide by that 3, we'll get a negative 1/6 plus 1/2 x squared plus 4x minus, if we were to rewrite this as x plus 2 to the 1/2, then that will give us the quantity x plus 2 to the 3/2. Dividing by 3/2 gives us 2/3. And then we want to evaluate this from -1 to 3. So let's plug in our 3's. The left side reduces to roughly 36 over 3. I know that can be reduced, minus 10 rad 5 over 3. And then the right-hand side reduces to a negative 12 thirds. No, sorry, 12 thirds, or 13 thirds. 12 thirds. And let's see, that gives us a 48 thirds minus a 10 rad 5 over 3. I know it's a lot of algebra in there, combining like terms. But if we went to our calculator, 48 thirds minus 10 rad 5 over 3, we do get the 8.55, the exact same value.